Welcome, everyone. So, I think the best thing that we should start with is to know how to differentiate statistical modeling and machine learning. Now, why are we even interested in studying statistical modeling? Well, you will know that statistical modeling it actually assists in understanding the ideas behind various techniques. So we just want to know when and how can we use those techniques. As you will see in the whole section of the course is that when it comes to statistical modeling, most of those models depend on some underlying assumptions. So with statistical modeling, we are able to accurately assess the performance of certain techniques. And also, statistical modeling has so many important applications, whether in science, in the industry, and also in finance. Say, for example, in identifying the risk factors for prostate cancer, spam detection systems. So, statistical modeling is able to be. So, with statistical modeling, we can also be able to develop some statistical methods that are able to detect spam emails. Also in finance, in maybe in banks, the statistical modeling is also used when it comes to detecting those transactions which are fraudulent. So now this is going to be so important because we want to be able to differentiate machine learning and statistical modeling. So when it comes to machine learning, in machine learning, we are developing an algorithm that can forecast. So it's able to forecast certain relationships without having to rely on any underlying distribution. However, when it comes to statistics, we make assumptions about underlying distribution. We all know the most famous distribution, which is normal distribution. So most of statistical models, they rely on certain assumptions. And also in machine learning, we are using algorithms. But when it comes to statistical modeling, we are using mathematical equations. So most people know that when it comes to statistical modeling, in most cases, people say it came from mathematics. However, when they refer to machine learning, they say it is a subfield of artificial intelligence. Because when it comes to machine learning, so machine learning has a very strong predictive abilities. But when it comes to statistical modeling, we just want the best estimate. Say we're looking for an estimate of a population mean or a population variance. So, so when it comes to also machine learning, we are mostly concerned about predictions. So we want to develop a certain algorithm that will see a new data and be able to predict what can happen in the future. But when it comes to statistical modeling, we just want to make certain inferences about maybe we are using a sample. So that is why statistical models, they learn mostly from the sample and we are able to draw conclusions about the whole population but based on the sample. However, when it's come to machine learning it's learned from the data. So with machine learning, that is why the more data you have, the the better your machine learning algorithm is going to perform. So machine learning algorithms they learn from the data and these algorithms are able to discover the patterns in the data. Also, this is the important point is that when it comes to statistical modeling, in most cases we will be doing hypothesis testing. So it just works when hypothesis testing. We're learning from samples. So how are we able to select the best model when statistical modeling and in machine learning? So in machine learning, we are learning from the data. So we have no underlying distribution. So when it comes to selecting the model, in most cases, we use cross-validation of predictive accuracy on partitions of the data. However, when it comes to statistical modeling, we look at the significance of parameters. So you will observe that in most cases, we will be using goodness of fit test. For example, when it comes to the logistic regression, we will be looking into Hosmer-Lemeshow goodness of fit test, and also looking into some statistical uh, tables or parameter estimate tables so that we can be able to detect the parameters that are significant by making use of p-values and so on.